intercept, and x is the slope of the next line, and f is the intercept. So that's how you get the slopes.
Yep.
And once you are done with that, you can just calculate the tau for your motor based on the bandwidth that you had in the previous lab, or the bandwidth from the tau that you had in the previous lab.
Yep.
The reason we are calculating this k tac, or the slope of the tac versus the RPM line, is because that gives you the relation between how many RPMs corresponds to how many voltages of your tac output, and the same slope of how many RPMs corresponds to how many volts of your input voltage. Ideally, they should be the same if your tac is good or your encoder is good, but as we see from this lab, there's quite a bit of difference. Also, now we go ahead in this lab and explore nonlinearities, because when you give very small voltages, the nice straight lines that you got in the previous plots that we showed you, they will start to have flat tops, and we'll show you that now.
Okay. To explore nonlinearity, we just need to change the value from the amplitude, the array amplitude that we have. Just we need to use a smaller value, like decimal values.
Yeah, you just go from minus 0.25 to say plus 0.25.
Yeah, and we use the same code that we have before.
Yeah.
So we just need to run.
An important point to note though in this case is that for the nonlinearity case, your amplitude must include 0. For your previous case, 0 is not necessary, because if you use 0, your motor will not turn and you will have a flat top in that, and that will be wrong.
Yeah. So just run the program using those values. It's gonna be the same. So if you see the output from the tachometer and the output from the encoder,
it looks like the motor is not moving, and that is exactly what we want to see, because we are trying to observe the dead zone.
because we're using smaller values.
Yeah,
so that's why the motor does not respond.
So we just let this set of tests run, and then we plot the graphs and see what we get.
Okay, we're done. Just after that, we have all of the data, and then we just need to run the same, almost the same problem that we use to get the WK and TK, but in this case, for this part, nonlinearity, to explore nonlinearity, we just need to plot the amplitude versus the WK. So because we have all of the data, we just need to run the program, and as you see,
this is no longer a straight line. It has a nice flat portion in between, and that is happening because of the nonlinearity, or the deadband of the system. If you give it some larger values towards the negative side, you will see a nice straight line on that end, and then a flat top and line rising above. But you basically get the idea of what we want from this lab. This was the previous line. These were the previous curves.
so after
Can
that,
you show the nonlinearity plot again?
yeah.
these are the new curves with the nonlinearity. So that's it, and we'll go ahead and show you how to deal with the LCD display.
Yep. For the LCD part, we have a power supply and LCD. To connect the LCD, this is the connector from the power supply. We need to follow the order of the color. First, it's gonna be yellow, and then black, red. It goes like that. That's it. This is the power supply.
Can you turn it back once more? Yeah, the order is written here, which you can find in the manuals. It says yellow, black, red on that strip. Yeah, and
Yep.
so if you don't do that, it will burn, so please be careful, and hook this blue and white RS-232 cable to the back of your computer, and that's it. You're all set.
Yeah.
And you will get some code from the TAA, this class, to run the LCD. Switch on the module first. Switch on the power supply.
The power supply.
Yeah, switch it on. Yeah, we have
This
this
is the switch.
big black switch. Just hit that, and it shows you this welcome message on the screen. And if you see that, that means your LCD device is okay. Now you can go ahead and run the code.
As my friends say, the code is gonna look like that. The TA is gonna give you the code, and we just need to run the code.
Yeah, it's
That's it.
very simple code, which just does some basic serial port output in MATLAB, and there you go. It prints out the bandwidth and the DC gain got from this lab, and it can also print some other fun messages if you want. That's basically it. After you are done, you should hit the power supply switch again and hit it just once and wait, and it takes some time to shut off, as you will see. Yeah, now it's off.
It's off.
And we're done
So,
for this lab.
done. Okay, bye-bye.
Bye bye, good day.